I'm going to do a video on improper integrals. The indefinite integral of 5x cubed minus x squared plus 10x minus 5 over x plus 4 is going to be considered an improper integral. And the reason for that is because the integrand is an improper rational expression. We have some polynomial divided by another polynomial, but what makes it improper is that the degree of the polynomial on the top is being raised to a higher power than the degree of the polynomial that is being raised to a certain degree on the bottom. So in essence, each polynomial is being raised to a degree. This x here on the bottom, it's being raised to the degree of 1. You just can't see it, right? And this x up here, it's being raised to the third degree. Now the degree on the numerator, it's higher than the degree on the denominator. So that's what makes it improper. How do we handle this? Well, okay, it's actually like not that easy. And that's why I wanted to make a video on it. I sort of came up with my own system on how to long divide this because we have to use long division in order to solve this improper integral. We could use synthetic division, but I'm going to use long division because synthetic division is only applicable in very specific circumstances, and long division works for everything. So what we'll do is we'll use long division to find the quotient and the remainder of the improper integrand. I'm going to box this up just so we don't get confused because there's going to be a lot going on. I'm going to shrink it too. I'm very particular about the way that I long divide an improper rational expression. I exploit the color spectrum as much as humanly possible because it gets kind of messy if you don't. And frankly, it gets kind of messy even if you do, but it allows you to categorize things in such a way where you can pinpoint what it is that you're doing, why you're doing it, and how you're doing it. So we're going to use the visible color spectrum. I'm going to go ahead and set this up. This is our divisor, and then underneath here is the dividend. The first thing to do is to divide the first terms. 5x cubed is one of our first terms, and x is another one of our first terms. So we'll do 5x cubed divided by x, because this is the first term in the dividend, and this is the first term in the divisor. The color placement is there for a reason, so hopefully it will make sense once we start working through this. What's 5x cubed divided by x? 5x cubed divided by x is going to be 5x squared. Where do we put the 5x squared? We put it up top here. These 5x squares are the same, that's why they're both surrounded in green. Now what we have to do is multiply 5x squared to the divisor. We're multiplying these together. The divisor is x plus 4, and the full thing is going to be surrounded in this purple pink color. And we're multiplying it to 5x squared, which is going to be surrounded in green. 5x squared times x is going to be 5x cubed. 5x squared times 4 is going to be 20x squared. What we're going to do now is subtract 5x cubed plus 20x squared from the dividend. So we're subtracting. Note that I'm adding zeros for placeholders. We're really going to exploit the color spectrum here. These are the same. I'm going to bring this down because this is long division. 5x cubed minus 5x cubed is going to be 0. Negative x squared plus 20x squared is going to be negative 21x squared. Then we're going to bring down 10x minus 5. We're going to keep working through this. Now what we have to do is we need to look at the first term. There's a new first term. The new first term is negative 21x squared. As for the divisor, the first term stays the same. It's just x raised to the first. Let us use a dark blue to indicate that this negative 21x squared is the same as this negative 21x squared that's over here. This x surrounded in red, it's the same x right here. The idea is that we can use these colors to apply a certain pattern recognition skill so that the same logic can be followed when given similar questions. Negative 21x squared divided by x is going to be negative 21x. That means that this negative 21x is going to make its way up here. Negative 21x up top. Negative 21x. negative 21x. They're the same. So let's take the divisor over here, x plus 4 times negative 21x, colors for clarity. Negative 21x times x is going to be negative 21x squared. And negative 21x times 4 is going to be 2, 4, 6, 8, 84. So we'll do negative 84x. What we'll do now is we'll subtract negative 21x squared minus 84x from what we have here in the dividend, left over from our first round of long division. I'm just putting the plus 0 for clarity. You don't have to do that. Negative 21x squared minus 84x right here, it's the same negative 21x squared minus 84x over here. Of course, I did add a plus 0 just so it lines up nicely. Before we get started, we're going to distribute this negative sign across all terms. This is going to become positive 21x squared, and this is going to become positive 84x. Now, negative 21x squared plus 21x squared is just going to be 0. 10x plus 84x is going to be 94x. Negative 5 plus 0 is just going to be negative 5. Now we're going to do our third round of long division. We must identify the first terms, and we have to divide the first term. So the first term in our dividend is going to be 94x, divided by the first term in our divisor, which is just x, as it's always been. I'll use gold to indicate that this 94x is the same 94x that's over here on the other side. As for the x in the dividend, we're just going to leave it as red. 94x divided by x is just going to be 94. So we're going to take this 94 and we're going to put it up top, plus 94. We're going to roll with this green still. We'll do this light green. I'll box up that 94 with a light green. Now what we must do is we must multiply this 94 to the divisor. So we'll take our divisor, x plus 4. I just realized something. This should have parentheses, as should this. Arithmetic's still the same though. We'll multiply the divisor x plus 4 to 94. 94 times x is going to be 94x. And 94 times 4 is going to be 376. So we'll take this 94x plus 376 and we'll subtract it to what's left in our dividend here. We'll distribute this negative sign to 376. So we'll have negative 5 minus 376. The answer to that is going to be negative 381. So the answer to this long division is going to be 5x squared minus negative 21x plus 94, with the remainder being negative 381. But what does this mean for our setup? We're trying to solve an improper integral. This is how this setup goes. We're taking the answer 5x squared minus 21x plus 94. Then to it, we're going to add our remainder, negative 381, over the original divisor. X plus 4 goes on the bottom. However, this can be simplified to 5x squared minus 21x plus 94 minus 381 over x plus 4. What we'll do now is make room, because we got what we need. It's in a cloud. What we'll do is we'll throw this into the integrand. So this is what we have now. It looks a little bit different. Now, how are we to solve this? Well, let's work on this one first. Now remember, this is the same thing as, what's the antiderivative of 5x squared? Well, first thing to do is factor out that 5, and then we'll multiply it times 1/3 x cubed. And I'm using the power rule for this. I'll go ahead and write out the power rule. PR stands for power rule, which I'll write out over here. And technically speaking, we also use the constant multiple rule. CMR stands for constant multiple rule, which I'll write out over here. So in this case, the constant phi was 5. Of course, this is going to turn into 5 over 3 x cubed. Same goes for this minus the integral of minus the indefinite integral of 21x. What we'll do is we'll factor out that 21, and then we'll take on the integral of x, and we have to use the power rule to take the integral of x. So it's going to become 1 over 2x squared. And that will transform into 21 over 2x squared. And then there's this negative sign that's going to come with it. So it's so far we have 5/3 times x cubed minus 21 over 2x squared. Next, we have to anti-differentiate 94. 94 is just that's the constant rule, and I'll write that out. I mean, really, if the power rule and the constant multiple rule are all indefinite integrals, then they should all have like a plus c, so long as they're indefinite. The definite, you don't need a plus c, but I just throw a plus c on there. You see how we're working with an indefinite integral? We're gonna have a plus c. Um, this is gonna become 94x, and then we'll just add a 94x there on the tail end of that. Now we'll do this one. So minus the indefinite integral of 381 over x plus 4. Now the thing about this is we could factor out that 381. Now we have the integral of 1 over x plus 4. And we want integration with respect to x. So there's a formula that can be applied to this. 1 over x plus 4. Now I'll write it in orange because orange is my dad's favorite color. How does it go again? It goes like this. I suppose today the Greek letter phi represents constants. So what's this become? Negative 381 times the natural log, times the natural log of the absolute value of x plus 4. And then we can bring that down and we can attach that to this, what we have for the first part, which is negative 381. So minus 381 times the natural log of the absolute value of x plus 4. And because this is an indefinite integral, as said before, we'll do a plus c on the end. This is our answer. Now that we have just evaluated an improper indefinite integral, I thought that we could evaluate a definite improper integral. This says to evaluate the definite integral from 0 to 1 of t raised to the fourth plus 2t raised to the third plus t raised to the second plus 2t, which is being raised to the first, plus 3 all over t squared plus 1. And we're integrating with respect to t. Now, due to the fact that the degree on the numerator is higher than the degree on the denominator, we are going to do long division to find the quotient and the remainder of this improper rational expression. So I'll write the divisor here, which is in the denominator, and then underneath here, I'll write the dividend, which is in the numerator. Now, in essence, it's the same sort of idea as before. We're going to start off with dividing the first terms. So we have the first term over here in the dividend is t raised to the fourth power, and the first term in the divisor, which is t raised to the second power. Now let's see. When you have a power divided by another power, you just subtract those powers. Let me write out a formula really quickly over here. If we have delta raised to the power of n divided by delta raised to the power of m, it's going to equal delta raised to the nth power minus the mth power. Greek and English alphabet unite. And that's exactly what we see is going on over here. T raised to the fourth power minus 2, which is going to be t raised to the second power. So we'll just put a t raised to the second up there. We're going to stick with green here. What we'll do now is we'll multiply t squared by the divisor. Okay, and then you see this rule here, this exponential rule. Well, the same works in reverse as well, inversely speaking. Delta raised to the power of n times delta raised to the power of m equals delta raised to the power of n plus m. So if we apply this to t squared times t squared, it's just going to be t squared plus 2. So it's going to equal t raised to the fourth. Next, we'll do t squared times 1, which is just going to be t squared. Now what we can do is subtract t raised to the fourth power plus t squared from the dividend. You see how there's a t raised to the third power here? Well, we don't have that. We're working with the degrees of t raised to the fourth and t raised to the second, so we'll put 0 t3 as a placeholder so we don't get confused, and then we'll drop our t squared right here, and then we can do 0t plus 0 for clarity. Now we're going to distribute this negative sign all across the polynomial that we're subtracting. 2 times t raised to the third plus 0, or in this case minus 0, is just going to be 2t raised to the third. And then we'll do minus 0 t raised to the second because these guys are going to cancel each other. And then plus 2t plus 3. We're going to take the highest degree in the dividend, which is going to be 2t raised to the third power. And then we're going to divide it by the highest degree in the divisor, which is going to be t squared. Oh yeah, and then for clarity, this t raised to the fourth plus t raised to the second is the same thing as this here. Remember, the zeros are just placeholders. I shall assign this 2t cubed a dark blue. And then t squared in the divisor is just going to be red like it's always been. So we'll end up with 2t. This 2t, it's going to come up here. So we'll do t squared plus 2t. Now what we'll do is we'll have to multiply 2t to the divisor. And then we got 2t times t squared, which is going to be 2t raised to the third, plus what we get when we multiply 2t to 1, which is just going to be 2t. And then we'll subtract it from what's in our dividend. We'll distribute this negative sign to all of these terms in the polynomial. And we'll end up with 0 plus 0 plus 0 plus 3, which of course just equals 3. So the remainder is 3. And our answer is presented up top. And then we can set this up as follows. This will be our answer. And now I will delete this and make room because we have what we need here. And then as before, we'll put it in a cloud. Perhaps the cloud can sort of indicate that we had to think about this in order to get it. Now I'm going to write this in a different form. These mean the exact same thing. What we'll want to do now is integrate the sum term by term and then factor out the constants. So I'll start here, and then we'll be left with 1 over t squared plus 1. Then we'll bring this down. And then we'll evaluate this 2t, factor out that 2. Go ahead with the integrin, and then just put a t on the inside. This is the fundamental theorem of calculus part 2. There's a formula that belongs to 1 over t squared plus 1. Let's look at this from the lens of the derivative. If the derivative of inverse tangent is 1 over 1 plus x squared, that would mean that the integral of 1 over 1 plus x squared, or in this case, 1 over x squared plus 1, is going to equal arctangent. That's why taking the integral is also called antidifferentiation. Because the antiderivative of 1 over t squared plus 1 is inverse tangent of t, that means we can write this as follows. That 3 is already factored out, so we'll have 3 inverse tangent of t evaluated from 0 to 1 plus everything that we had from before, which honestly, and not to be lazy, but very briefly, I'm going to give this 3 arctangent of t evaluated from 0 to 1 special attention. It's going to take precedence over these integrals because it's a little bit more complex. It's at this point that we're going to introduce the Greek letter pi into the equation, representing 3.14159265359, and so on. The reason for this is because we introduce pi because of the integral of 1 over t squared plus 1. It's the arctangent function, and it's the angle whose tangent is 1. And if it's the angle whose tangent is 1, it's going to be pi over 4 radians. Pi over 4 radians times 3, thus 3 pi over 4 radians. 3 pi over 4 plus. Now we'll take the integral of t squared. Well, we already know what the power rule is because we've learned about it previously in this video. So let's take the integral of this in our head. It's going to be t raised to the third power over 3, and for the definite integral, it'll be evaluated from 0 to 1 plus. We got the integral of t, which we can evaluate this via the power rule. So we'll do this one in our heads, but remember we're going to multiply this 2 that's been factored out. So it will be 2 over 2 t squared evaluated from 0 to 1. 3 pi over 4 has already been worked through. And now we'll evaluate t raised to the third power over 3 at its bounds. And we can do that in our head because it's just going to be 1 raised to the third power over 3 minus 0 raised to the third power over 3, and that's going to equal 1/3. And we can evaluate 2 times t squared over 2, and we can evaluate at the bounds from 0 to 1. This is a form of 1 here, so really what this is just t squared evaluated from 0 to 1. And if we evaluate t squared from 0 to 1, it's going to be 1 squared minus 0 squared, which is going to equal 1. So we'll have plus 1. How do I add 1 to 1/3? Well, I have to find a common denominator, which is going to be 3 in this case. And what you do to the top, you must do to the bottom, right? So then this is actually going to be 3 over 3, a form of 1, plus 1/3, which is going to be 4/3. So we'll have 4/3 plus 3 pi over 4, and that will be our answer. Thank you so much for watching my video. I really appreciate it, and I hope you have a good day.